Let's discuss electrostatics. Electric charge. I want you to think of charge like teams. So one team is positive and the other is negative. So same teams don't get along. They push away, which means they repel. Opposite teams attract, they pull towards each other. The amount of charge is measured in coulombs. One electron has a tiny charge. So the formula is E is equal to 1.6 times 10 to the power of negative 19 coulombs. That's like splitting one coulomb into billions of pieces. So how objects become charged? First of all, friction. When you rub two things together, the electrons move. For an example, a balloon rubbed on hair makes the balloon negative and your hair positive. Then there's conduction. When a charged object touches another, it shares its charge. An example is a charged rod touches a metal sphere and passes charge to it. Then we have induction. A charged object can push or pull charges in another object without touching it. An example is to bring a charged rod near bits of paper and the paper gets attracted. Conductors versus insulators. Conductors let charges move freely. So metals are like highways for charges. And insulators do not let charges move easily. So rubber and plastic, which would be equal to blocked roads for charges. Looking at Coulomb's law, this law tells us how strong the force is between two charges, and the formula is given there. So bigger charges are equals a stronger force, and closer charges equals a stronger force. Farther apart equals a weaker force. So K multiplied by 9 times 10 to the power of 9 is just a number scientists use to make the math work. So like charges push apart, unlike charges pull together. Now we look at electric field. Imagine every charge is like the sun. Around it, it creates a force field, which is an invisible space where it can push or pull other charges. The closer you are, the stronger the pull or the push. So field direction away from plus charges toward subtracts charges. So field lines is like the map of how a test charge would move. The principle of superposition is if more than one charge is around, each gives its own push or pull. So the actual force is just the total of all these pushes and pulls combined. Everyday uses of electrostatics is in photocopiers or printers, where the ink or toner sticks only where charges are. Then spray painting, where paint droplets are charged so that they spread evenly. And in lightning, nature's huge static discharge between clouds and the ground. So in short, electrostatics is just about charges standing still, how they interact and how we use them in daily life.